Hi guys, this is Shashank and today we're going to make a bi-directional person counter based on Arduino. Now there are a lot of person counters available, visitor counters available on Google. For example, let me just do a quick search for you. All right, there's one based on the 8051 microcontroller, and then there's one here on circuitdigest.com where the maker of the bidirectional person counter has used an LCD screen over here and a relay and two proximity sensors. We're not going to use an LCD screen, although I have one over here. But what we're going to do is we're going to use the serial monitor today, the serial monitor on the Arduino IDE. So let's start coding and remember this code has been completely written by me, so you guys are free to utilize it and modify it as per your wish, and do post it in the comments below. And if you find any issues while executing this code, you can mention them in the comments and I'll reply back with the answer. So let's start. All right, now over there on Circuit Digest, we saw that they're using two proximity sensors. So we're also going to use two proximity sensors. However, the code which we're going to write today is going to be completely different from what is there on their website. However, the integers and all will pretty much be the same. So let's start. So our first sensor will be integer sense1 equals 7. Then our second sensor will be in sense2 equals 8. Now we need to mention both the sensors as integers because the value will change. It will either be high or low, and while we're writing this, we're not going to do an analog read, which is possible with an IR proximity sensor, but we're going to do a digital read for it. We'll come to that later. Now we have a relay or an LED. I'm going to write relay. However, I will be using an LED. Okay, let me just write LED. It doesn't matter. Okay, so LED on pin 2. Now it's not gonna work until I tell the setup that these numbers are linked with the pin mode. So we're gonna do that in the next step. Now we need to mention a counter. This whole system is based on counts. So if it's at 0 or lesser than 0, the system is going to display just 0. If it's more than 0, say it's 1 or 2 or 3, it's going to display that, but it's not going to go in negatives. So that is a small enhancement which I've done over here. That'll come further in the program. Okay, so now we need to start our serial port. So we're going to write serial.begin at 9600 baud rate. Now if we don't write this, the serial monitor is not going to print anything. So this command is very important. Now we mention our pin modes. Now we have sensor 1, we have sensor 2, and we have an LED at pin 2. So first we're going to write pin mode. It doesn't matter where you write it, but sometimes it does in some cases. Sense 1 is an input pin. So we'll write pin mode sense 1, comma, input, bracket close, and semicolon. Again, pin mode, we have sense 2, which is our sensor 2. That is also our input pin. It's an input device for us. Now the next one is our LED, which is connected to pin 2. So we're going to write LED as an output device. Now the thing is, you guys can use an LCD instead of a serial monitor. You'll probably have to include the LCD library provided in the Arduino IDE, and the code for the LCD is on the Circuit Digest website. So it's the bidirectional counter. You can pair my code with the LCD code on the Circuit Digest website, and you can make an LCD work. All right, let's move on. So we have set our pin modes. Now whatever we write, if you're familiar with Arduino coding, if you're familiar with coding in general, you should know that void setup contains things which have to be done once. And then we come to the void loop. Void loop is the place where we put our code, which is going to run throughout while the Arduino is on. Alright, so we've defined the integer values. Now the ones mentioned on the top are global integers, and the ones we're going to mention within the void loop are only going to work inside the void loop. So let's have two integers which are going to capture the value of the sensors. So integer val1 equals, what should the value be? It should be whatever the proximity sensor is providing our Arduino. So digital read. Now I told you before that we're going to do a digital read on this. We're not going to do an analog read because we don't require that. So sense 1. Then we'll have to delay it for 1 second. It's good to delay it, and 1 millisecond doesn't do too much of a harm. Although if you put too many delay commands, it's really going to take a toll on your Arduino and it's going to slow it down. Next, we need to mention the value, integer value 2, which is digital read sense 2. So this is our digital read for the sensor number 2. Then again, we delay it for 1 millisecond. Okay, let's move on. Now, we have conditions. We have certain conditions while we are writing any code. We have to imagine those conditions in real life situations and then how to convert them into numbers, and how to convert it into a language which my computer can understand. So we have two sensors, sensor 1 and sensor 2. So we're going to create the situations. If the object moves from sensor 1 to sensor 2, what happens? If the object moves from sensor 2 to sensor 1, what happens? If the object moves from sensor 2 and is standing in front of sensor 1 and sensor 2, what should happen in case it goes, if the object goes right, or if the object decides to go to the left hand side. Now the program which is available on that website, basically it doesn't do this. It doesn't have the deciding factor wherein if somebody is standing in front of both the sensors and if he decides to go left or if he decides to go right, what should we do? That program just keeps on counting, plus 1, plus 2, plus 3, plus 4, again on the back side, minus 1, minus 2, minus 3, minus 4. Now I don't think it goes to minus. However, I'm just uh, let's just try this further, and then we'll figure out how we've tweaked this code for it to work properly. Now the next command is, if val1 equals high, that means if the person has entered the first sensor in front of the first sensor, what should we do? We should add a counter, obviously, because as soon as the sensor reads something, we need to add the counter to it. So we'll write counter equals counter plus 1. Then we delay it for 1 millisecond. Then now the person is standing in front of the sensor 1 and he plans to move further and he reaches the sensor number 2. Now sensor 1 and sensor 2 are placed at such a distance that if an object crosses them, if the object is standing in the middle, it's actually enabling both the sensors at the same time. So what we're going to write is, if now this is a nested if statement here. If val1 equals high, which we already know that it's already high, and at the same time val2 equals high. Okay, so now you must be wondering that I have put two equal signs over here as well as here. Why two equal signs? Because we want the Arduino to check if the value of 1 at that particular time is high or if it's low. Now if both of these statements are true, then what should we do? We should just not do anything. So what we're gonna do here is we're gonna open a parenthesis and we're gonna tell the Arduino that it's gone from 0 to 1 when val 1 was high. Now if val 2 also goes high, just subtract that 1 by 1, counter equals counter minus 1, so that we are at a stage wherein the Arduino is actually not doing anything. So it just goes from 1 to 0, then 1 to 0. Now this is done. This is the first command, wherein if I go from left to right, and if there's a delay in between which is of 500 milliseconds, which is going to come later in the program, and I'll tell you why. Because if we write a delay of 500 milliseconds right now, it's never going to read the value 2. It's just going to miss it, because that distance from the sensor is it's just going to cross without the 500 second millisecond delay being over. So what we need to do is we need to write the conditions only. So the first condition is if val1 is high, then counter equals counter plus 1. Now if val1 and val2 are high, just reset it. So counter equals counter minus 1. Hi. All right, so let's move further. Now the other condition is we're going to write else if over here, because these two conditions are connected, this condition and the condition which we're going to write now, wherein val2 equals high. That means if the sensor 2 is equal, check if the sensor 2 is high, which means the person is coming from inside the room and going outside. So what we're going to do is we're going to write counter equals counter minus 1. I'll just put this in brackets because it's subtracting and it's just safer to do so. Press Ctrl T to auto format it. Okay, so counter equals counter minus 1. Then again we delay it for 1 millisecond. We move on to the next line, wherein we write the same code what we wrote previously, but the opposite of it. So what we're going to write is if val1 equals high, and what am I writing? Sorry. If val oh, my caps lock is on. Val1 equals high, and at the same time val2 equals high. So what should the Arduino do? It should again do nothing and just cancel out what has been done already. So if it has subtracted, what we're going to do is we're going to add a counter. So counter equals counter plus 1. There we go. Now this till now was fairly simple. There are two situations wherein the person is coming from here and the person is coming from the other side. So what should the Arduino do in case he plans to just stand there? So we've set up a base for that right now. We're going to move on and write the conditions in case after he's standing in front of both the sensors, if he goes this way, what happens, and if he goes this way, what happens. So we're going to close the else if command with a parenthesis, and we're going to move on to another if command, wherein or if statement, sorry, wherein val1 equals high. If that is true, then you tell the Arduino to delay 1 millisecond. If once that has been done, again if val1 equals high, check if the value of the sensor is high, and at the same time check if val2 equals high again. So what should the Arduino do in this case? It should subtract a counter. Why should it subtract a counter? Now I'll have to figure that out. Okay, no, I don't really need to do that because I've written the code. So what I wanted to do is I wanted to subtract a counter first. Counter equals counter minus 1 and close the bracket, and then delay it for 1 millisecond, and then counter equals counter plus 1. Okay, so why I've written subtract a counter first and then add a counter for, after that, is because what we're going to write now is going to define it. Delay 1 millisecond, sorry. Now if the person plans to go into the room, so if okay, so right now what it's going to do is it's just going to keep on subtracting one and adding one, so the counter does not go anywhere. So it won't change the value until and unless the person does something. So what we're going to do is we're going to write if value 1, value of the sensor 1 equals low, that means the person has started to move towards the sensor number 2, which is near to the room, and val 2 equals high, which makes it very obvious because at one point of time val 1 is going to be low and val 2 is going to be high at the same time. So we'll open up parentheses and ask it to, no, since the person has gone inside, we need the counter to increase by 1 because there's one person who's gone inside. Then parentheses, 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 and we've written our first set of the code. Now we need to move on. Now there are four situations in this wherein if val1 equals high, and if the person goes towards the room or away from the room, so these are two situations. Now if val2 equals high and the person goes back into the room or goes away from the room, so like this we have to create four situations. Right now we've just created one of them. So let's move on to the next situation, which is the same one, else if. So we're going to write else if instead of an if command because we need one of this, either this or this command to work. So what we're going to do is we're going to write an else if sorry, else if command wherein val1 equals high. So we've asked the Arduino to check again if the value of the first sensor is high right now. If it is, then just delay it for 1 millisecond, and after the delay check if val1 equals high, and at the same time val2 equals high as well. So check if the person has reached in front of both the sensors. So once that is done, counter equals counter minus 1, then we delay it for 1 second, 1 millisecond, sorry, I miss that every time, and then we write counter equals counter plus 1. Press Ctrl T just to format it, looks nicer that way, neat and clean. Okay, so let's move on. Now since we're at the we're at a place where the counter will not go anybody, what should happen in case the person goes towards the room or away from the room? So what we're going to do is we're going to delay it for 1 millisecond again. Okay, now we'll write our command we'll write our situation basically. If val2 equals low and val1 equals high, so that means if the person comes into the is going towards the room and he suddenly decides to not enter the room and go back, what should the Arduino do? Arduino should, what should it do? It should add a counter, or should it subtract a counter? I think it should subtract a counter because obviously counter equals counter minus 1. Why I've asked it to subtract a counter is because on the top over here we have already mentioned that if val1 equals high equals high, then counter is equal to counter plus 1. So that means every time val1 or val2 will be high, the counter is going to add or subtract 1 respectively. So we need to mention here that counter equals counter minus 1 if this situation is true. Now this command does not end here, we still need to delay it for 1 second. So we'll 1 millisecond. Here we go. Okay, so this is one set of the situations done. Now we have the second set of situations. There are two situations wherein in both the situations the value 2 is high first before value 1. So what we're doing here is basically telling the Arduino that if value 1 is high before value 2, or if value 2 is high before value 1, at the same time making sure that if both of them are high, what to do. So the code has been written in such a way that all these situations can easily be rectified in that case. So let's move on to the uh, first situation of the second set, wherein if val2 equals high, that means if the person is coming from the room, then delay for 1 millisecond. Now after you have delayed it for 1 millisecond, if again you need to check if both the sensors are, if the person is standing in front of both the sensors. So while 1 equals high, and at the same time while 2 equals high. In this case, what should the counter do? Counter should add 1. Counter plus 1. Now once this is done, just delay it for 1 millisecond here, and then move on to neutralizing the command. So how we neutralize it? We just write counter equals counter minus 1. Okay, so we've neutralized the command. But in case that is happening, if the value 2 equals low, and at the same time val 1 equals high, what should the Arduino do? Now the person has come in from the room, is coming out from the room, he's standing in front of both the sensors. The sensors are going like plus 1 minus 1, the counter is going like plus 1 minus 1 plus 1 minus 1, but the person just suddenly decides to just walk away from the room. What should it do? Counter equals, what should the counter do? Now if I haven't mentioned over here that if val2 equals high, then counter equals counter minus 1, but over here I've mentioned that val2 equals high and counter equals counter minus 1. That means every time val2 is going to be high, I don't need to mention it again, I just need to write so if every time val2 equals high, it's gonna go minus 1. So what we need to do here is we need to add a counter. So counter equals counter plus 1, and I've closed it. Now this is one of the situations. Now the other situation, if we want one of the situations to be true at one point of time, so we're going to write else if instead of an if. If you write an if, then you know it's going to process all the commands at the same time, and your program is not going to work. So if val2 equals high, again it's the same situation, parentheses open, we're going to delay it for 1 millisecond. Again we're going to end. Now if val1 equals high and val2 equals high, so in case the person is again standing in front of both the sensors, you know, because he's mad, so counter equals counter plus 1. Oh, okay, so again it's high, so we need to neutralize it. We need to tell it to do something, otherwise it's going to execute the commands on top. So counter equals counter plus 1, then counter equals counter minus 1, and control T to auto format it. Remember, keep pressing control T in given intervals just to have your code neat and clean. And it's a very good habit to put two backslashes and write whatever that counter goes to 0, so that you have a track of what you're doing. It just gets a little easier. I've written this code and printed it on the site, so I don't really need to do that, but it's a very good habit if you do it. Okay, so the next command is, now if that is true, what should we do? If val1 equals low, and at the same time val2 equals high, what should the Arduino do? It should subtract a counter. So here it subtracts a counter, and we delay it for 1 millisecond again. Alright guys, so the major part of our program is done. We've written the code, and we need to check if it works, but it's not going to work because we haven't told the Arduino that in case the counter is at 0, or if it's at -1, if it's at 1, what should it do? I mean, if the counter is at 0, should it turn on, should it turn off? So we need to write a small piece of if and else if command. So let's start. If our counter, the counter is less than or equal to 0, which less than means it's going to be it goes to -1. So when you count people, you can't go to -1. He'd have to be dead for that. You'll have to kill him just to go -1. Don't do that. So what we're gonna do is we're gonna digital write relay low, wherein once we write this command, what the Arduino is going to do is, basically Arduino is going to switch it off as soon as the counter hits less than 1, or if it's equal to 0, or if it goes to -1. Now as of now it will go to it will go to the negative numbers. However, we can change that by writing a simple command over here, that counter equals counter multiplied by 0. So every single time that the counter comes down to 0, or it goes less than 0, for example -1, it's going to multiply itself with 0 and become 0. So it's not going to go into negatives at all. Now we need to delay it. We need to delay it for 500 seconds. But remember, the time should be such that in case the person crosses both the proximity sensors, what should happen is he should cross them within that span of 500 milliseconds or whatever time you mentioned, and the distance of the proximity sensors should be set accordingly while you're placing your sensors on the table. Okay, so this is done. Now we need to serial print it after we write the delay. Otherwise, it's just gonna go 0 0 0 0 0 1 1 1 1 1. So we don't want that. What we want is we want to print it once within those 500 milliseconds. So print. Okay, so there are two commands which we can use. Either use serial.print, or you can use serial.println, print line. What happens is, if you write serial.print, then it's just going to print in one single line. If you write serial.print line, it's going to move on to the next line and print one below the other. So serial.print line, we need to print our value of the counter. So in brackets, we need to write counter. Once that is sorted, we can close the parentheses of this if command, and once that parentheses is closed, you need to write else if, the other condition wherein counter is greater than 0. Now we need to write two greater than signs, because we want the Arduino to check if it's greater than 0. So, and similarly over here also we want the Arduino to check if it's greater than or equal to, smaller than or equal to 0. Otherwise we would have written a smaller than sign and equal to sign in two different brackets, so in two different if commands rather. So let's move on. Counter is greater than 0. What should the Arduino do? It should digital write the relay, the LED, sorry, I've been writing LED. I've changed what I've printed here is actually relay because I made it accordingly. But right now I've just connected an LED to my Arduino. I'm going to show you that in a minute. So LED high. Now we've got the LED high over here. We again need to delay it for 500 milliseconds. It's applicable for both the situations. And serial dot println counter. So every time either of the commands are executed, we need to print the counter. And we have to close our loop. So we've closed our void loop with the last parentheses. Let's see if it's connected. Yes, it is. So it should show this small semi, what do we call this, oval, uh, if the two parentheses are connected. So this one is connected to this one is connected to this is fine, this is fine, this is fine. It's just a good idea to check your parentheses. Yeah, and they all look fine to me. Now what we're gonna do is we're gonna upload this code. So let's see if it works. Now I'm gonna lower down the camera. Okay, so it says VA1 was not declared. What did I write wrong? Okay, so just don't be scared. Just check out what the problem is. I forgot to mention L over here. Let's upload it again and see. Uh, Okay, sometimes it takes a little while for some reason, especially on this version of the Arduino IDE. I was using a higher version before this, but I wanted to use that. I wanted to do something with Arduino on the breadboard, so that wasn't working properly with the 1.8 version. So I switched down to 1.6.5. But it's a little slow for some reason. I don't know. Maybe it's a problem with my serial cable, or I'm not sure. It does write, but it's a little slow. Okay, so let's just wait. Okay. Okay, it works here. Now we're coming from inside the room and we decide to go back inside. It's not gonna switch on, switch off, sorry. It's not gonna change the counter as well. Oh, it goes to 3 accidentally because I kept my hand a little longer on the sensor too, but it's not gonna change as long as I'm doing it. Similarly, if somebody comes from this side, it's not gonna, it shouldn't change the value. Okay, so it doesn't in most of the situations. It's just yeah, so it doesn't. Okay, now the person decides to come in, stop, and then move inside. Okay, so the counter does move to 2. Now the person decides to come from the other side, stop in front of it, and go out. So the counter decreases. Okay guys, so I'm happy that the code works. I had not tested it before this properly. I did test it. I did give it a quick hand swipes and all. It did work at that time, so I thought it's probably working. I thought I'll just give it a try on the video and actually see what happens. So I hope you enjoyed. Do like, comment, subscribe, and share, and I'll see you in the next video. Goodbye.